Let's finish up this chapter with talking about the third line of defense. Like I've been saying, this is very specific response, specific to a specific pathogen or piece of a pathogen or specific part of a bacteria. Okay. Um, what is an antigen? An antigen is usually something that we call that is non-self. Okay, a pathogen, something that is foreign to us. Now, there's going to be two adaptive responses. So there's two main responses in this third line of defense. Okay, the first one is going to be cell-mediated immune response, and this is going to be pretty much taken care of by something called T cells. To be more specific, cytotoxic T cells. Okay, this is cell-mediated because you're going to see that it is the T cells that are going to be attacking the cells. Okay, and then we have something called the humoral or antibody immune response, and these are the stars here are going to be the B cells, and the B cells, their antibody immune response, because the B cells themselves don't attack. They don't attack anything. What they're going to do is the B cells will become something called, if they get activated, if they find a pathogen, then they will get activated and become plasma cells. And plasma cells can then secrete, guess what? That's right, antibodies. And guess what? Antibodies also are not something they're going to be attacking anything. Antibodies are just going to be a bunch of proteins that are going to be tagging along. They're going to have different functions. Some of them are going to neutralize a pathogen, or they may agglutinate a pathogen, or they may just be like tags, tags saying, hey, you know what? This is a bacteria. This is something bad. Macrophages, come over here. Come over here and eat this in. Okay, phagocytize this cell. Okay, so that's what they do. But antibodies itself are not going to be destroying anything. They're just like tags. Okay. Okay, cell-mediated immune response. When you ever hear cell-mediated immune response, you're going to be thinking about T cells, cytotoxic T cells. What are cytotoxic T cells? These are white blood cells. Okay, they're part of the WBCs, white blood cells, or leukocytes. Okay, they are born in the bone marrow, but then eventually go to the thymus and they mature in the thymus. They're going to be direct attack. Okay, so cytotoxic T cells, guys, cytotoxic T cells. They're going to be direct attack, attacking directly and destroying infected cells. Now, they will attack endogenous antigens. What does that mean? It means antigens produced inside of the cells. And this is key. This is key because when you think about T cells, you're thinking about your protection against, for example, cancer cells, against virally infected cells. And so a virus will infect the cell, right? And the cell is going to start producing nasty stuff, right? Nasty proteins and everything. But they come from the inside. So you see why these are endogenous antigens coming from the inside, because they're made inside of a cell. And when they show in the membrane of the cell, there's where the cytotoxic T cells recognize them and attacks them. Okay, so know that the cytotoxic T cells, are mostly effective against cancer cells and virally infected cells. There are different types of T cells. The most common ones are helper T cells. They regulate, they assist, they coordinate the activation of other cytotoxic T cells and also B cells. So technically, mostly, this is going to be the keyword, activation. Okay, they're going to help activate cytotoxic T cells. They're going to help activate B cells. So they help activate different cells. Okay. Then you have memory cells. Memory cells are like you probably can guess. They're gonna memorize. They're gonna memorize a path. They're gonna stay there after the fact. Okay, memory T cells. These are T cells that remain long term after an infection has been eliminated. And this is the reason why we do vaccinations, guys. So we can actually create some memory cells, T cells or B cells. And whenever you see this pathogen again later in your life, guess what? You have memory cells that are going to recognize it, and your response is going to be way faster, okay? Because you recognize it. Okay, and then we have cytotoxic T cells, and these are the bad ones. You know that. Well, I mean, they're bad ones they're bad for the for the enemy, but they're really good for you. These are going to be attacking infected cells. Now, cytotoxic T cells, what do they do? How do they attack? Very similar to those natural killer cells. Okay, what do they do is this: they eliminate um, large numbers of infected cells. Okay, so they're going to be head-on, okay, head-on attacks. What is their killer mechanism? They puncture a hole in the plasma membrane of the infected cell, and then they activate apoptotic enzymes, okay, inducing apoptosis in infected cells. What is apoptosis? Cell suicide. So T cells going to send a bunch of enzymes that are going to lead this reaction inside of an infected cell. The infected cell is going to get this. He's going to start. The infected cell is going to get the message, and he's going to commit cell suicide. Okay, and that's how you kill these bad infected cells. So if you look at my diagram here, this is a T cell. Perforin, which we talked about already, is going to be a protein. Okay, that's going to make a pore. Perforin makes a pore. Then the granzyme, which is where a bunch of enzymes. Okay, I'm going to put these enzymes. Granzymes are they going to be able to go through here. Okay, and granzymes are going to activate these apoptotic enzymes in this virally infected cell. And these enzymes are not going to be induced into apoptosis. So now this virally infected cell is going to commit cell suicide. Okay. I was just checking the spelling of commit. Okay, and after infection, some activated T cells, some of these activated cytotoxic T cells, give rise to memory T cells. And these memory T cells remain in the body ready to mount an attack quickly if the antigen is encountered again. Okay, so remember these memory T cells, there are not that many. There's just few of them. Okay, like you see, some very few actually are left out as memory T cells, and they stay there. And then eventually, when you get this infection again, or this virus again, or this type of virus again, then what happens is you're going to produce way more cytotoxic T cells way faster because you memorized it, you know it already. And this is a very simple diagram of what is the activation of cytotoxic T cells. Now, check this out. What did I say about the helper T cells? They do what? They help. They help activate, right? So we have helper T cells. Helper T cells. Remember, helper T cells are not cytotoxic T cells. Okay? Helper T cells are cells that help activate. Okay? So this helper T cell recognizes the antigen, okay, the viral antigen, for example, in the macrophage, for example. Okay, it recognizes this virus, it knows it already. A cytotoxic T cell over here also recognizes the virus. Okay, it's the same virus, the same antigen. Okay, same antigen. You see, they're both little like that. They're both little triangles. Okay, they both recognize it. Okay, so the cytotoxic T cell now has been presented this antigen, but it's not going to really mount an attack unless it gets signals from the helper T cell. Helper T cell starts sending something called interleukin-2, which is a signal that is going to be activating these cytotoxic T cells. Now the cytotoxic T cell is activated, okay? It's activated, and some of them are going to become memory cells for later on, and the other ones are going to become this nasty looking thing that is going to go and find those virally infected cell. Okay, and again, use that perforin granzyme type of mechanism to kill this virally infected cell. Okay, so remember from this picture, just very basic. I'm not going to any kind of detail really. Just know the main parts. Okay, you need to have a helper T cell to help these cytotoxic T cells to get activated. Once it's activated, now it can go out, make cytotoxic, say make some memory T cells, make some cytotoxic T cells, and the cytotoxic T cells can then find this virally infected cell, and it's going to do the perforin granzyme mechanism to kill that cell. What about the antibody immune response? When you hear antibody, you are not going to think about T cells. Okay, forget that T cells. Antibody immune response involves B cells. B cells are also white blood cells. They mature in the bone marrow. They do not directly attack the infected cells. They don't do that. Okay, they mark the pathogen for destruction. That's what they do, and that's what the antibodies do. They're going to be marking the pathogen for destruction. Okay, they're going to be marking the pathogen for destruction. B cells become plasma cells. So a plasma cell is an activated B cell, okay, which produces antibodies. Okay, plasma cells produce markers called antibodies. Antibodies are markers. They're alert. They alert complement proteins, like I was saying before. Antibodies are going to be like, hey, complement proteins, come over here. There's something going on here. And they also going to activate macrophages and actual killer cells. Okay, so that's what antibodies do, among other things that I'm not going to go into detail. They're directed against extracellular pathogens. And remember that, because that's a big difference. T cells attack intracellular stuff, right? Things that come from inside of the cell. Now, this one, okay, the B cells are going to attack extracellular pathogens, come from the outside, okay? Like, for example, bacteria, for example, viruses that are not inside of a cell. And B cells also depend on these helper T cells for activation. This is a very simplified picture of activation of B cells. Here you have a macrophage. The macrophage is going to phagocytize this microbe or parts of the microbe. It's going to destroy it, and then it's going to present it to a helper T cell. Okay, helper T cell now knows what this cell is, or what this pathogen looks like. And remember, helper T cell, they're not going to do anything. They're just going to help activate. Okay, and in the other hand, here now you have a B cell, and the B cell has receptors here, okay, that recognize this antigen, and they're also going to be able to phagocytize this antigen, okay, and they want to present it. And now that it knows the antigen, now the helper T cell here is going to be able to come and help activate this B cell. In other words, the B cell really cannot do much anything at this stage, because he needs to get this extra activation. He needs to get this extra switch, let's say, by the helper T cell. Okay, the helper T cell will secrete something called interleukin-2, activated this B cell. Okay, now this B cell, remember what I told you, a B cell is gonna get activated into something called a plasma cell, and the plasma cell is what makes antibodies. Then the antibodies are going to go out, and they're going to be attaching to bacteria, to the pathogens. They're going to start marking it, okay, marked for destruction. And some of these complement proteins are going to be able to see this antibody. Some macrophages or neutrophils are able to see this antibody, and they're going to be able to come and digest this thing or destroy this thing via complement system mechanisms or phagocytosis. Okay, and some of these plasma cells, some of these cells become memory cells. They stay there. When you see this virus again or this pathogen again, then you get to it's memorized, so you'll make more of these plasma cells way faster and way more antibodies than in the first response. Antibodies. Antibodies contain, this is what an antibody looks like. It contains two antigen, remember there's two antigen binding sites, okay? This is where the antibodies bind to the antigens. And this is a antibody, okay? This is an antibody. It has heavy chains and light chains. You can see that by the color coding. The most important part I think I want you to take out of this is this part, which is the antigen binding site. Okay, the antigen binding site, which is what's going to be very specific to a specific pathogen or specific antigen. Okay, so antibodies are very specific to a certain antigen. Okay, they flag those foreign bodies for destruction, but they're very specific to specific antigen because every single antibody is going to have a different, slightly different antigen binding sites. And you guessed, if you were thinking, wait a minute, it has two. Yeah, that's great because it's like having two arms, right? So it's able to grab the two antigens. Can it do that? Absolutely. It can do that. Okay, it's like two little arms. Okay, so know the shape of an antibody, know what the antibody antigen binding site is and what it's for, and that it's variable. This is the main word. Is very variable, okay, or specific to something. That means it has to be variable between one and another, right? So the antigen binding site is very variable. It's a variable part of the antibody. Oh, and by the way, I'm sorry, variable. So this is an antibody. These two, obviously, these two antigen binding sites are the same because they belong to the same antibody, but a different antibody is going to have a different antigen binding site, okay? Or a different antigen binding sites. That's what I meant by variable. Two different antibodies coming from two different cells, they have different antigen binding sites. Okay, memory cells and immunological memory. Both cells, what they're showing you here is both B cells and T cells produce memory cells. We already know that, which provide the body with the ability to recall previous antigens exposures. Okay, a primary immune response, small amounts of antibodies are produced. So the first time that you meet an antigen, you're going to produce small amounts of antibodies. Okay, it's going to take several days to produce enough antibodies to fight antigens. And this is what you see actually over here. Okay, a primary immune response to antigen A produces antibodies to A. Okay, so what happens here is, let's say you get an infection or you get to see this antigen A on day 2. Well, it takes like 5 to 6, 7 days to start a reaction. Okay, around day 6 or 7, like around 5 days after the exposure, you start making antibodies, and you make up to this amount of antibodies. Okay, so it took a little longer, and then obviously then it goes down. The infection is over, the number of antibodies go down. Now, what is a secondary immune response? Well, memory cells respond. So primary immune response basically by new T cells, new B cells. But secondary immune responses are always led by memory cells. Okay, and these are going to respond to another exposure to a previously seen antigen, to the same antigen as before. It's going to be way faster and it's going to be way more effective than the primary response. Okay, and what does this mean? It means this. Check this out. Around day 28, you get to again, you get infected with antigen A. Okay, so what happens? Well, this time it's going to take like 2 days to start a response, right? Like around 2 days, 3 days. And not only that, look at the amount of antibodies you're going to be making. All that amount. Okay, so the secondary immune response to antigen A produces way more antibodies to A. Okay, this is big. And why is this? Again, because of the memory cells, because you have a bunch of memory cells. Now, antibodies to B, okay, what the graph is telling you is it's all specific, right? Not because you have seen antibodies to antigen A means that you're going to be ready to make antibodies B right away. You don't. You have to meet it first, right? You're not going to date someone unless you meet someone, right? So what happens here is they're showing you that this person also meets antigen A. So your body starts making antibodies, and again, it's about the same time. Let me just erase this really quick. Let me erase this really quick. Oh, come on. Okay, I'm going to do it with blue. That way it makes more sense. Technically, here, this day, 28, you meet antigen B. Okay, you get antigen B. This is the primary immune response to antigen B, and it takes again another 5 to 7 days to start a reaction or start producing antibodies, and you make about this amount. Okay, so what happens is if you get to meet, I don't know, antigen B around this time, well, the second response is going to be faster, and it's probably going to be humongous as well. Okay, because of the memory B cells. Last but not least, vaccines. Vaccines is nothing but an introduction of a dead or disabled pathogen into the body. What does vaccination trigger? It triggers an immune response against a pathogen or an antigen without an infection occurring. Okay, body responds to making antibodies against that antigen. And kind of the goal of vaccinations is to produce memory cells. And that, ladies and gentlemen, is a brief introduction to the immune system.